In this lesson, we're going to continue from section 3.3, Common Factors of a Polynomial. In this lesson, you will learn how to model and determine strategies to factor a polynomial. In the first part of this lesson, we looked at different strategies and how to multiply a polynomial. But in this lesson, we're going to look at strategies how to factor. Keep in mind that a polynomial can be of three types. It can be a monomial, a binomial, or a trinomial. So factoring polynomials, there are two strategies, very similar to multiplying. First, we can use an algebra tile method, or we can remove the greatest common factor, the GCF. Keeping in mind from Unit 3, we've discussed the greatest common factor, and a factor is a number that can be used to divide evenly into a number. So if we were going to compare 6 and 8, we would look at numbers that would divide into 6 and 8 to be factors. So if we looked at 6, we could say, well, 1 times 6, 2 times 3, same thing for 8, we could do the same. And when we compare the factors, we're going to look for the highest factor that is shared between 6 and 8. This process is going to be very similar for a polynomial. Instead of looking at a whole number, comparing it, we're going to look at expressions. So if we look at our first method, we can use algebra tiles to display what we have for our polynomial. So if we looked at 2x squared subtract 6x plus 2, we know that we would have 2x squared tiles, 6 negative x tiles, and 2 positive 1 tiles. So when we want to factor, factoring means we need to group things. We need to group it into equal groups. So if we have 2, 6, and 2, we need to determine how many groups we can break that into. Can we do 2 groups, 3 groups, 4? Well, if we look at 2, 6, and 2, we know that we can only divide them into 2 equal groups. So in this case, we're going to have 2 groups, and each group is going to contain a trinomial of x squared subtract 3x plus 1. As we can see from the algebra tiles, those 2 groups got to have the same tiles in each, and when we look at what they have, it has to equal the same trinomial. So therefore, our factors are going to be 2, since there are 2 groups of the same, and the group itself, x squared subtract 3x plus 1. And if you want to check your solution, all you would need to do, similar to the previous lesson in this section, is to multiply 2 by that trinomial to determine if you will get 2x squared subtract 6x plus 2. That's a good way to do a little error analysis for yourself. Our next method is removing the greatest common factor. So if we have negative 20c to the 4 times d, subtract 30c to the 3 d squared, subtract 25cd. And if we need to factor that completely, we need to look at the greatest common factor that can be removed from each term. That's our first step. So negative 20, negative 30, and negative 25. What is the highest factor that can be removed there? Well, from negative 20, negative 30, and negative 25, we are able to remove negative 5. Next, we need to look at the c variables. We have 4 c's in the first term, 3 in the second term, and 1 in the third term. The highest we can remove there will be 1c. If there's only 1c in the third term, we can't remove any more from that. Very similar, we'll look at the variable d. We have 1d, 2d, and 1d again. The highest variable d that we can remove will be 1. Therefore, the greatest common factor has to be negative 5cd. And as mentioned in the steps there, the greatest common factor that is removed from each term must be the same. So it can't be 2 or 3 different factors, it must be the same from each. And we're going to use the distributive property to write the expression as product. So once you've determined the greatest common factor that's going to be removed, you're going to write that as a monomial outside the bracket. And since we started off with the trinomial, inside the bracket there must be a trinomial left. And as we move, we're going to divide the common factor out from each term. So negative 20 divided by negative 5 is positive 4. Remember now the laws of exponents. Once you divide, you have to subtract the exponent. So if you have c to the exponent of 4 and you're dividing by c, you are subtracting, so there's only 3 left. And of course, d divided by d, there's nothing. Next, we have negative 30 divided by negative 5. That will give us positive 6. If we have 3 c's and then we have 1 being taken out, that will leave us with 2. 2 d's and we are taking out 1, there is left with 1. And negative 25 divided by 5 is positive 5. And we're already removing CD, so therefore there's no variables left in the third term. And very similar to our last example, if you want to check your solution here, you can multiply the monomial inside the trinomial and determine if you get back what you originally started with. So in summary here, to factor polynomials, you can remove the greatest common factor from each term, write the expression using the distributive property to write the factors as a product. The greatest common factor can be found using prime factorization as well, if you're familiar with that from Unit 3. Verify the factored expression using the distributive property. So multiply back in the monomial that you removed to determine if you have the original back. And if you want a more visual representation, you could use the algebra tile method as well.